We're going to square some expressions with radicals because there's some common mistakes people make. So let's look at if we have 5 times the square root of y, quantity squared. Okay, here's what it's not. It's not 5y. Okay, here's the reason. Squared means to multiply something by itself. So we're going to have 5 root y times 5 root y. Well, then the 5 times 5 gives us the 25, and root y times root y is y. So that's what the answer is. Now notice here, since we're dealing with just real numbers now, in this section, y has to be greater than or equal to 0 in here. Now this one, y, we don't know that it had to be greater than or equal to 0. It just says y. This is the reason we get extraneous roots, is because we have a domain restriction that sort of got thrown away when we squared it. Here's another expression with a radical in it that we're going to square. We'll do square root of x minus 3 plus 7, that quantity squared. Okay, here's what it's not. It is not x minus 3 plus 49. You can't distribute a square over addition. You can't just square this and square that. Here's the reason. Well, squaring really means that we're multiplying something by itself. Let's FOIL. So this times this, we're going to have square root of x minus 3 squared plus 7 square root of x minus 3 plus, this times this, square root of x minus 3 times 7, and then plus 49. Okay. We've got more than just this. Okay, so square root of x minus 3 quantity squared will give us x minus 3. We have 7 times the radical expression and 7 times the radical expression, so we're going to have 2 of those, so we double it. So this will be plus 14 square root of x minus 3 plus 49. And we can do one more step. We've got some like terms. We can combine the 49 and the negative 3. So we'll have x plus 14 times the square root of x minus 3 plus 46. So we did not lose the radical. It's still there. And that's a mistake.